Hey guys, this is Mr. C, and in this video we're going to be talking about how to solve literal equations. A literal equation is an equation that has basically letters in it, variables, and there's usually more than one. And so, for example, 2x plus y is equal to 5. This is an equation that has two variables in it, x and y, and I have a choice. I could either solve for x or I could solve for y, which means get one of these by itself. I'm choosing to solve for x. And so in all these problems, I'll be telling you which variable that I want to solve for. I want to get by itself. So this one says solve for x. So I want to get that x by itself. So I'm going to start out with 2x plus y equals 5. So if I want to get x by itself, I have to get rid of the constant first. Well, this constant isn't really a constant anymore, it's a variable. I still need to get rid of it though. So I don't want to divide by 2. I'm going to subtract y on both sides, like that. When I do that, I'm going to bring down my 2x equals, and now I have a choice. I can either write 5 minus y or negative y plus 5. I'm going to choose to write 5 minus y. And it really doesn't matter which one you put first, as long as it's mathematically correct when you put them together, like that. Now I'm going to divide by 2 to get x by itself. 2's cancel. And x is equal to 5 minus y over 2. Okay, so now x is by itself, everything else is on the other side, and believe it or not, there are many times in mathematics where you need to do something like this before you can even get the problem going. So this is a very useful skill to have, especially for those of you going into geometry. All right, so here we have one, and it says solve this for y, 3x minus 4y is equal to 7. So I want to get that y by itself. So I have 3x minus 4y equals 7. So I need to unwrap this thing until I get y by itself. Well, I really need to get rid of this 3x first before I can start talking about that coefficient. So I'm going to subtract 3x on both sides. Those cancel. Negative 4y equals, and I'm going to write 7 minus 3x because it's just easier that way. And now I can go ahead and divide both sides by negative 4. The entire side by negative 4. Those cancel, and y is equal to 7 minus 3x over negative 4. Now that's a perfectly acceptable answer right there. Y is by itself, everything's on the other side. But there is another option. Because you have a minus right here and a minus right here, what happens is that minus can be what I call absorbed into the numerator by doing this. Y is equal to 3x minus 7 over positive 4. That's actually a better answer because there's one less negative in the whole thing, even though these two answers are the same thing. They're equivalent. This answer is a little bit better. But at this level, I mean, nobody's going to expect you to just, right from the start, be able to do things like this. So either answer is fine. But in the back of a textbook, that's probably the one that they would put in there. All right, here we have negative 5x plus y is equal to negative 54. And this time we need to solve for x. And so let's get x by itself. So we have negative 5x plus y equals negative 54. So what I'm going to do is I'm going to take y away from both sides like that. Bring down my negative 5x equals, and let's just say negative 54 minus y. Okay, now let's divide by negative 5, both sides. Let's cancel, and x is equal to negative 54 minus y over negative 5. And now, here's a really cool thing you can do. You see how you have 3 negatives here? All 3 items are negative. You can go ahead and take all 3 of those away and make them all positive. Because that's the same thing that's going to happen is if you multiply this by negative 1 over negative 1, that's exactly what's going to happen. You're going to get x is equal to positive 54 plus y over positive 5. And then there's another way you can write it. You can take the 54 and y, and you have a commutative property that says you can actually write it like this. Y plus 54 over 5. So any of these 3 answers at the end will be correct for me at this level, that's fine. Okay, so we're kind of hitting these linear equations hard. lots of examples because they're the most common. All right, so we need to solve this one for y right there. So the first thing I'm going to do is I'm going to subtract a 6x on both sides. Those cancel. Negative 5y is equal to negative 6x plus 1. And I just kind of chose to write it like this time. Instead of writing 1 minus 6x, I wrote negative 6x plus 1. It doesn't matter. Divide by negative 5. And you get y is equal to negative 6x plus 1 over negative 5. Now let's see if we can write this a little bit differently too. So because you have this negative here, if you multiply everything by negative 1, which is completely legal, you would actually get y is equal to positive 6x minus 1 over positive 5. And either of these answers are okay. Neither one is any better than the other, but in the back of a textbook, they would probably write it like this because they're minimizing the two negatives as just one right there. So just something to think about. All right, so now we're going to get into some formulas here, which are also literal equations. And this time we want to solve for a. So of this entire equation, you have a times b plus c in parentheses. So what I'm looking at is if I can get rid of the b plus c part, then the a will be by itself. So I'm going to write p is equal to a times b plus c. Now if I can divide both sides by b plus c in parentheses, like this, that whole factor right there will cancel out on this side, and I'll get p over b plus c, I don't really need the parentheses, is equal to a. And a is on the right hand side, but a is by itself. And since a is by itself, I have solved this for a, and I'm done. That's it. Okay, so this is your classic equation for the circumference of a circle. You want to solve it for r. You want to get rid of the 2 pi in front of the r, both of them. Well, the good news is we can get rid of both of them at the same time. Remember, pi is just a real number, and so we can cancel both those out. And we get c over 2 pi is equal to the radius of the circle. And that one's done. Here's the geometry formula for the sum of the interior angles of a convex polygon. S is equal to 180 times n minus 2, and we just solve it for n. Now we could distribute the 180 to both these terms right there, but I'm not going to do that. What I'm going to do is, well, actually, you know what? Yeah, let's go ahead. Let's hold off on distributing first and see how we can do this. Let's have S is equal to 180 times n minus 2. What if I divide both sides by 180 first? Okay, those will cancel, and I get S over 180 equals n minus 2, and since nothing's in front of the parentheses anymore, it just comes out of the parentheses. I can add 2 to both sides, and now I get S over 180 plus 2 is equal to n. So that's one way to do it. So, but what if a student decided to distribute first? Would they also come up with the same answer? Well, let's see. S is equal to 180n minus, and 180 times 2 is 360. Let's add 360 to both sides. Let's cancel. So S plus 360 is equal to 180n. And now let's divide both sides by 180. Okay, those guys cancel. And we have S plus 360 over 180 is equal to n. So do we have two equivalent answers right here? Is this answer right here, I can never draw straight lines. This. Are these two answers the same? Well, let's see. You can split this up into two fractions, s over 180, right there, plus 360 over 180 is 2 right there. And so yes, they are the same. Either one is just as good as the other. I'm not really sure what would be in the back of a geometry textbook for this one, so I would just take either one of those as fine. All right, so here we have an equation that looks like the area of a triangle. And so let's kind of shift markers here for a second. And I want to solve this one for the base of the triangle. So I have A is equal to 1/2 BH. What I probably want to do here is I want to get rid of that 1/2 first. And to get rid of a 1/2, we generally multiply both sides by 2. If you multiply both sides by 2, 1/2 and 2 are multiplicative inverses, so they will cancel out and make 1. So now we have 2A equals BH. Okay, so now we need to divide both sides by H, because remember, we're solving for B. So divide by H, and 2A over H is equal to B, and then that's our final answer for that one. Okay, so here we have a formula from physics. S is equal to 1/2 AT squared, and this would be in the unit on kinematics. Doesn't matter. We need to get A by itself. So A is sitting right here. So if S is equal to 1/2 AT squared. And so let's not get wrapped up in that T squared yet. We need to get rid of that 1/2 first, don't we? So we're going to do the same little trick that we did before. We're going to multiply both sides by 2 to get rid of it, to move it over to the other side. All right, so now, let's see what we got. We're going to get 2S equals, both those make 1, AT squared. We need to get A by itself, and that T squared is holding us up. So we're going to divide both sides by T squared. Both those guys cancel. And so we have 2S over T squared is equal to A, and then we're done with that one. Okay, here we have actually 1, 2, 3 variables, and we need to get rid of everything but the M. So we have 3/5 M plus A equals B. All right, so to get rid of everything but M, we need to get rid of A first. So minus A minus A. So we have 3/5 M equals B minus A. Now we need to get M by itself, and we have that 3/5 there. Generally, when I see a fraction like that, to get rid of it, I'm going to multiply by the reciprocal, which is the multiplicative inverse, 5/3. But notice, when I multiply this side by 5/3, I don't want to just multiply the A, I want to multiply both of these guys by 5/3. Otherwise, it's not an entire side. Okay, those are both going to make 1. So M is equal to, I'm going to put the 5/3 in front and B minus A in parentheses after it, like it normally looks, and then that's fine for that because you do have M by itself. So we're good there. Okay, so this time we need to get Y by itself, and it's way up here in this numerator. So we have B times Y plus 2 over 3 equals A. So the first thing that's holding us up is that 3 down there. Not the 2, not the B, but the 3. So we need to multiply both sides by 3 first. Okay, so let's see what that looks like. These will cancel. Bring down my BY plus 2 equals 3A. Okay, so now we need to get, again, we need to get Y by itself. So let's get rid of the 2 first. So we have BY is equal to 3A minus 2. And then we just need to divide both sides by B. And we get Y is equal to 3A minus 2 over B for our final answer there. Okay, last example. Although there are many, many of these out there, we have the equation for the area of a trapezoid, and we need to solve for H. So if we need to solve for H, we gotta get that H by itself. So A is equal to 1/2 H base 1 plus base 2. All right, so if we want to get h by itself, it's got that 1/2 sitting there again. And so we know what to do here. We need to multiply both sides by 2. Okay, so when we multiply both sides by 2, we get 2a equals, both of those cancel, multiplicative inverses, h times b1 plus b2. We want to get h by itself, so we got to move all of these parentheses underneath the 2a. So we're going to divide both sides by everything in parentheses, just like this. Both those cancel, and we wind up with 2a over b1 plus b2 is equal to h. And then that's our final answer for that one. So that concludes our little video on literal equations. Remember to like my video and subscribe to my channel if you haven't already. See you guys later. Bye.